Hello, space explorers! Today we'll embark on a journey to the very beginning of the universe, guided by one of the most extraordinary stars ever discovered, the Methuselah Star, HD 140283. Its story is not just a fascinating lesson in astronomy, but also proof that the universe still hides secrets we can't fully explain. How is it possible that, according to some measurements, this star might be older than the universe itself? What can it teach us about the birth of stars and galaxies? How do scientists determine the age of such a distant point of light? And why does Methuselah still spark debates among astronomers? Buckle up. This is a story about scientific paradoxes, cosmic mysteries, and the limits of our understanding. What is the Methuselah Star? Official designation: HD 140283, nicknamed Methuselah, after the biblical figure who is said to have lived the longest. Located about 190 light-years from Earth in the constellation Libra. Apparent magnitude: 7.2. Visible with a small telescope or binoculars, but not with the naked eye. Type: subgiant, a star older and larger than the Sun, but not yet a red giant. Why is Methuselah legendary? Since the early 20th century, astronomers have known it was very old and metal-poor. Its spectrum shows extremely low amounts of metals, elements heavier than helium, indicating it formed shortly after the Big Bang, when heavier elements were rare. In 2013, the most accurate Hubble Space Telescope measurements shocked the world. The star's age was estimated at 14.46 plus 0.8 billion years. For comparison, the current estimated age of the universe is about 13.8 billion years. Could a star be older than the universe? It sounds impossible, but that's the paradox that has fascinated astronomers and the public alike. How do scientists measure the age of stars? It's a mix of science and detective work, chemical composition. After the Big Bang, the universe was almost pure hydrogen and helium. Heavier elements, metals, are created in stars and supernovae. A star with almost no iron, oxygen, or carbon must have formed before the universe was enriched with metals. In Methuselah's spectrum, the iron content is about 1/2000th that of the Sun. Stellar evolution models. Stars go through predictable life phases. Models predict how long each stage lasts depending on mass and luminosity. Methuselah's place on the Hertzsprung-Russell diagram suggests an age over 13 billion years. Precise distance and brightness using parallax from the Hubble Space Telescope, we know Methuselah's distance precisely, which allows us to calculate its absolute luminosity and therefore age. Physics and nuclear models. Theories of nuclear fusion, convection, core development, and overall life cycles let us estimate how long the star has been burning to reach its current state. The paradox of Methuselah's age. The most shocking claim: some measurements suggest the Methuselah star is older than the universe itself. This sparked massive debates. Are our methods so imprecise? Or is there something we don't understand about early universe physics? In reality, it's the sum of many small uncertainties, distance, brightness, composition, that when combined can create an impossible result. What does Methuselah actually look like? Surface temperature, about 5,700 K, very similar to the Sun. Mass, about 0.8 times that of the Sun luminosity, over twice as bright as the Sun radius, about 2.2 times that of the Sun chemistry. Almost pure hydrogen and helium, extremely little iron, no observed planets or dust disks. Where and how could Methuselah have formed? Most likely it was born in one of the first mini-galaxies, which later merged to form larger galaxies like the Milky Way. Methuselah is a halo star. It orbits the galaxy's center on a highly elliptical path, often far above the galactic disk. Such stars survive for billions of years because they are low mass and burn fuel slowly. Methuselah, compared to other ancient stars, HD 140283 isn't the only prehistoric star, but because it's relatively close, we can study it in detail. Other record holders like SMSS J0313000.36-670839.3, are even poorer in metals but are much further away and much dimmer. Most of the first-generation stars exploded as supernovae or were consumed in galactic mergers. Why is Methuselah so important for science? It helps calibrate models for the formation of galaxies, the first stars, and the distribution of heavy elements in the early universe. It helps refine cosmological constants like the Hubble constant and the universe's expansion rate. It shows that even today, witnesses of the universe's earliest times still exist in the Milky Way. What if we found an even older star? Discovering a star definitively older than the universe would require rewriting physics and cosmology textbooks. So far, anomalies like Methuselah show how challenging measuring the age of stars is, and every new telescope generation could further push the boundaries. Methuselah in popular culture and science, its story, appears in many books, documentaries, and scientific articles as a symbol of cosmic longevity and the mystery of the universe's beginnings. It's a metaphor for patience, survival, and the fact that the sky above us still holds countless secrets. Philosophical questions and challenges. What are the limits of human knowledge about the cosmos? Will we ever directly detect true population 3 stars, the first generation which vanished billions of years ago? How many more relics of the Milky Way's birth are still waiting to be discovered? New telescopes and the future of research telescopes like the James Webb Space Telescope and future giant observatories will allow us to study the chemistry, motion, and history of the oldest stars in greater detail. Such research may help us directly detect supernovae from the first star generations, or even find traces of galaxy formation on new scales. Summary: what does Methuselah mean for us? It's a symbol of cosmic endurance. It survived the birth of the Milky Way, the Sun, and Earth. It's a living witness to a time with no planets, no galaxies, and no heavy elements, only hydrogen, helium, and darkness. It proves the universe is still full of surprises and mysteries. Even in our cosmic neighborhood, we may find the keys to the history of the cosmos. What fascinates you most about the Methuselah Star? Do you think we'll ever find even older stars? How do you think science would change if we discovered a star truly older than the universe? Drop a comment, like, and subscribe, and keep watching for more cosmic mysteries.